Intellyx Brainwave Problem Solvers Episode 3 with Eric Newcomer from WSO2. Welcome to the Intellyx Brainwave. We're here for another action-packed episode of our podcast, videocast. Today we're joined by Eric Newcomer. He is the new Chief Technology Officer at WSO2. We go way back working with Eric in the past in previous roles, directly and indirectly. Prior to joining Citi in 2012, he was Chief Architect for Investment Banking IT Division at Credit Suisse. And before that, he was the CTO at Iona Technologies. Before that, a distinguished engineer, architect at Digital Equipment Compact Computer. So welcome to the show, Eric, and great to have you on with us.
Thanks, Jason. It's great to be here. Thanks for asking me. Sorry if there's any construction noise in the background here occasionally, but life in the big city.
Right, very good. Well, it's great to talk to you again, Eric. We go way back. I think we worked together a bit when you were at Iona, or at least in the web services standards efforts. I know you. I remember you as being the god of WS-Transaction. You were like the guy who understood everything.
I wrote that spec. Yeah.
Yeah, exactly.
But yeah, I was involved. I kind of made the pivot from transactions to web services when I joined Iona. The reason for it, when I was at Digital Compact, and which is now part of HP, I was involved in a Microsoft partnership activity. So I knew a lot of guys at Microsoft and Iona. When I joined them, they started talking about the pluggable ORB, the configurable ORB that was the base of their new product. And one of the configurable protocols they kept showing was SOAP. And this was in 1999, 2000. I said, what is that? And they said, well, we don't know for sure. Microsoft is talking about this. They have this spec and they haven't released it. So I said, I know people at Microsoft. So I called them up and I got hold of this spec and I brought this to the guys at Iona. And they said, here you go. Why don't you get somebody assigned to this who understands languages and protocols and data mappings, that stuff. I'm the transactions guy. And they said, who do you think we are? Digital, we're a small company. You have to do this. So I said, okay. And so I did both jobs for about a year, and it seemed like web services was going to turn into something, and I kind of pivoted to that.
Yes, you mentioned ORB, and only us gray hairs or no hairs will remember what that is, right? Object Request Broker. And
yes.
It was part of the CORBA movement that predated web services. And
Yes.
We don't have to spend too much time on the history lesson, but this all leads up to the story of APIs, which is the modern story. So help us sort of get some historical context. We had ORB and CORBA, we had web services, and now we're talking about APIs. So what can we gray hairs and no hairs teach the millennials about APIs given this historic context?
Main thing is it's all about the design. If you get the design right, that's 90% of what you need to do. This was true even for DCE before CORBA, if you want to go back that far, to kind of the original distributed systems efforts that were trying to become standards. These kinds of things had a lot in common. They were coming out of industry. They were more LAN-based protocols, kind of trying to, if you will, bring the mainframe apps out of the distributed world, the same qualities of service through distributed computing. And then we got into this whole web services versus REST battle in the mid 2000s. I'm sure you remember that as well. And now REST APIs are the way to go. That's kind of the end result of that. I don't know if it was a battle or just a slowly emerging standard. Now, the design practice is the same, but the technology is different, and APIs on top of REST have some really different characteristics than what the old DCE, CORBA, Java EE had in the past. So that would be the second adjustment, which is, first of all, get the design right, API first, interface first, as we used to say. Figure out what you want to expose to your clients, the main design practice, not what you're wrapping on the back end. That's the wrong way to do it. Then once you've done that, the second thing to understand now is how is REST different? If you're coming from that world of the old distributed computing, how is REST different than the old stuff?
Yeah, so that API first, back in the web services days, we called it WSDL first, and that's an important core best practice. But as I remember, as the transition from web services to REST, as REST became sort of more predominant, it was still hobbled by its HTTP centricity. HTTP never really being designed for that, right? It's a stateless protocol, and it closed down the interaction as soon as it was complete, and it didn't really lend itself to APIs. And then it became sort of core to the REST approach. But today, we don't necessarily have to worry about the constraints of HTTP with REST. So how have you seen that APIs evolving? We had WSDL, XML-based web services, then we had this HTTP-based story that was very limited, and then now we have modern RESTful APIs. So what's going on there?
Well, I can see first of all, I have to say I can see which side of the fence you fall on for this REST for web services debate. I got this a lot from the OMG guys back in the day when I was first starting with web services. I would go to the Corba meetings, the standards meetings. They'd say, Eric, what the hell are you doing with this crappy HTTP protocol on this text-based payload? Why aren't you using IOP, and a good binary protocol is much faster with qualities of service? And I would say, sure, you guys just get IOP and the Corba stuff to be as widely adopted as HTTP is, and no problem. So you kind of have the adoption phenomenon was there because of the web. It drove the adoption of HTTP much more than Corba was ever adopted. So you had this kind of de facto, this stuff is out there. But this is also of interest is how this happened, because HTTP, as you know, comes from this whole other world of computing around SGML and document-oriented standards. And it was invented as a way to share research documents. And the way you exchanged state was you had a document, you downloaded it, changed the state, uploaded it back, and somebody would figure out what was changed in the document so they could update their database. And it's based explicitly. When SOAP first came out, I remember working with Don Box to try to do transactions early because he knew I was a transactions guy and he was a SOAP guy, and he thought, let's go do this. And I had recently finished doing a transaction internet protocol at IETF with Tandem and Microsoft. So we tried to do this, and we called it SOAP Tip. Of course, sorry, couldn't help but laugh a little bit about this crazy name we came up with. But pretty soon after we got a little bit far into it, we realized it was really impossible to do this because the transaction internet protocol, like classic distributed two-phase commit protocols, depended on a shared session state to coordinate the two-phase commit protocols. And if you lost that session, it was a two-pipe model. You had a pipe for the application data, a pipe for the transaction coordination protocol. And if you lost that pipe, you rolled back. It's the same with OMG, with OTS, Java EE, XA, all of it was the same. And without HTTP having persistent sessions, as you correctly pointed out, as a limitation, I would say the other side of that, it's an advantage. And that's what I want to talk about a little bit when we get to that. But certainly in the days when it came out, and us classical distributed computing guys were looking at it, we're going, what the hell is this? This is not at all what we're used to. It doesn't have the right qualities. If you read the REST thesis from Roy Fielding, he explicitly says we don't want to have shared session state because it interferes with scalability. And he was talking about a WAN-based protocol. Up to that point, we've been talking about LAN-based distributed stuff, right? And I think he was correct that for a wide area network, you cannot really have a shared session state, have a two-pipe model. You have to have everything on one pipe. The interesting implication of this, for me, is that it's trying to simplify the picture. Now, you might say it just pushes the complexity around. Now, let's say if you're doing transactions as a RESTful resource, the application has to keep track of the state, the log state, and pre-log state. If anything goes wrong, the application has to do the rollback, essentially, instead of the system doing it. Is that better or worse? I think both cases can be made. The case for being better is kind of to do with the assumptions that were made in the old distributed computing environment. We got to put all these utilities into the system. Got to have transactions, security, reliability, but all of this stuff relied on the session, shared session state. And I think, do we really need all that complexity in the first place? Because this was kind of almost a knee-jerk reaction. You go to Corba, they reinvent all these capabilities. .NET reinvents all these capabilities. Web services reinvent all these capabilities. Do we really need those? Some applications don't, some applications do. So why not make it a problem for the applications where they need the complexity and simplify everything else?
Yeah, so shared session state, that is a phrase that just sends goosebumps down my spine, given a lot of this history. And I remember when REST became, you mentioned some of the origins of REST. So when REST sort of first hit the scene, one of the core principles was HADOS, hypermedia, as the engine of application state. And it seemed so promising and innovative that instead of a shared session state external to the interacting endpoints, we could just use the hypermedia themselves, that is, within the message itself, to maintain state. And it didn't really prove to be that workable in general. And now we have microservices interacting via modern APIs in, say, a Kubernetes context, which is an inherently stateless architecture, where it externalizes state via a whole different way of thinking about state information. So again, we don't have a shared session state in Kubernetes, and we never could, right? Kubernetes is designed in such a way that it just would be alien to have a shared session state across the entire, I don't even know what. So what are we doing So what are we doing today with shared session state? Is cross that out? It's an anathema, but we still have to deal with state. We still have to commit transactions in a microservices environment. So what are we doing?
Well, I think for transactions, we really should be looking at transactions as a resource as the model for this. But I think there is a complication, and you kind of touched on a little bit. I wanted to respond to the Kubernetes thing first of all, and the microservices thing, because I think there's something else that's pretty widely misunderstood in the industry. And some of it is the same reason web services were misunderstood back in the day, because vendors are trying to kind of bolt them on to their existing software so they can keep selling the stuff that they have. So I don't want to pick on IBM, except I like to pick on IBM. In my career, I've been a competitor of IBM, so that's kind of comes naturally. I read their red book on microservices, and they got all the concepts right. And they got to the example section, and they want to show examples on Java EE with HAPs. No. These are not. That's not how you do microservices. But of course, they want to keep selling what they have. But microservices, what's missed often about this is microservices come out of the right way to develop applications for commodity data centers that are comprised of hundreds of thousands of small PCs. So you have to distribute the workload across them. And I follow this very closely because I know Adrian Cockcroft at Netflix, and I know some of the Amazon guys. So they were, when they did the famous monolith to microservices, they created small units of work called AMI, Amazon Machine Instances. That was their whole focus, break the work up into those things. Only later did they call it microservices. The real evolution of these things comes from the right size of work for these commodity data centers comprised of PCs. Now, that's why you don't have a shared session state either, because these fabrics or these networks of computers work only if you have a stateless kinds of interactions, because part of what they do, part of what makes them work, is they allow for failure of these components. So if you look at some of the early design docs for Google Files, they say our requirement was to keep the system going in face of component failure, even because we built this system on these cheap components that are subject to frequent failure. So they built their own file system, and they wrote multiple copies of data out onto multiple machines. So if anything failed, they had another copy available. Does Oracle work on Google File System? No. we have a problem. We have a mismatch between the old world and the new world around how state is managed because of getting the benefits out of this cheap hardware by allowing things to fail and keep going. So I think people tend to miss, that microservices come out of that world as many other things do, such as Kubernetes. So back to this API point, though, if you're talking about APIs, microservices, and it's really kind of two levels to this, and it's this constant debate. People still are debating, what's the right level of granularity for a microservice. But my frame of reference tends to be the Netflix talk and the Amazon guys that built their website, and I think those two worked pretty closely together in the Netflix migration. And I remember asking Adrian about this, what was his model? And he said, well, we have this AMI, this unit of work. We put a RESTful interface around us. That's our coarse-grained service. And behind that, we have a bunch of fine-grained services using the Java interface to talk to each other. So you have some, and some people will say the microservice is those fine-grained things behind the coarse-grained interface. Some people will say the microservice is that coarse-grained interface, and behind that is just a lot of smaller things making that whole thing work. But I think both are important to think about, because you could have a mixed environment where you use HTTP for the coarse-grained service and gRPC or something else for the finer-grained services. It's not a one-size-fits-all thing, and there's a lot of considerations. What are you doing? Are you doing event-driven architecture? Is Kafka the right way to do things? And so on. So there's a lot there, but I think the fundamental characteristics of the commodity data center as visible in the cloud is things that really need to be taken into account when doing these designs.
Yeah, you bring up a lot of interesting points. I mean, one of the points you made is how Google and really all of the cloud providers figured out how to architect a scalable infrastructure based upon low-cost commodity hardware, which is now sort of the core of the cloud. We just build a resiliency-based architecture instead of a high availability architecture. And if we're looking for high availability, we have to jump through extra hoops to achieve it in this context.
That's all different too, how you achieve high availability. Yeah.
Right.
Exactly.
But there's also this discussion of fine-grained versus coarse-grained services, and I think that's a point that the audience who hopefully will find this podcast may still be confused on, and I still see a lot of confusion. And there's confusion it seemed to really take off as people started moving to a microservices architecture before they really figured out the elements of a cloud-native architecture that required more than just the microservices. But when microservices came on the scene, people were just building lots and lots of microservices, and they ended up with this big mess, right? It was point-to-point integrations and things bogged down, and it didn't scale. And it was just like, the pre-web services days all over again. It's like they hadn't learned the lesson from the point-to-point integration days. And part of the challenge was this notion of fine-grained services versus coarser-grained, and the bounded context principle, which I hadn't really seen that people talking about it in the web services days, but it became very important once people realized that to do microservices right, they needed really to move to this cloud native architecture that was more than just a bunch of microservices. So I mean, what are you seeing in terms of the modern approach? And feel free to talk a bit about what WSO2 is doing as well, because I know they're sort of on board with this modern approach to architecting microservices-based infrastructure.
So some of this relates, when you mention bounded context, that relates to team organization as well, the famous autonomous teams.
Well, Conway's law, the software and the organization mirror each other, right?
Yeah, exactly. And if you don't really tackle that part of the concept, you may have trouble with the whole microservices concept as well. In terms of how do you approach this, WSO2 has a methodology called Celery, where we look at cell-based organizational structures that determine the responsibilities of the different teams within one of these autonomous units. So we give a little more detail on, here's your microservice bounded context, here's the type of skills you need within that microservice to work on whatever it is you're working on, whether it's a GUI component or a database component, and try to drill down a little bit to help formalize the structure of these teams a little bit. In terms of the granularity of a microservice, though, I think I'd like to get back to maybe some of the earlier points we were starting to touch on around how do you do the design of these things. So when I was at Citi, I was chief architect in treasury and trade for several years. And we, at one point, started a program of doing target enterprise architectures. And we were doing a lot of these at Credit Suisse. That was part of their architecture culture. And the reason for doing them was to try to help map out the strategic investments and make an informed decision when you're spending money on a project as to whether it helps you get to a strategic place or it's a tactical fix or whatever. And of course, you're going to have some of each, but without a framework for that discussion, you may not know whether your decision is aligning to where you want to go or it's just something else. You don't know whether you're going somewhere. So we did a lot of these. And the way we started this was to take a blank sheet of paper and say, let's forget about our existing systems. I know that it's very common practice in enterprises to say, hey, I have an existing order entry system. I have an existing payment system. I want to modernize that. I want to take it to the next level. Let's evolve it, to the next step and let's, do something with it, build on what we have. But often what we have is not what we want. And if we're iterating toward the target, you can't really get there. You have to stop and say, where do we really want to go? And then work back to where we are and then figure out that journey. So we always try to start with strategically, where does the business want to be in 5 years, 3 to 5 years? And let's say if you're in payments or liquidities management or something like that, you would talk to the business people and they would say, gosh, we would really like to have our customers be able to define their own liquidity portfolios to see the structure of all their accounts in a certain way so we don't have to do this. It's not in the product now, but something strategic for the company. We say, okay, let's map that out as a service. And the great part about SOA, which is also inherited by microservices as a design practice, you can align your business service to a software service very easily and say, hey, I have a service here. Just give simple examples. I'm a bank. I've got services for paying you. I've got services for paying credit card debt, for paying your mortgage, for transferring money, for cashing in, translating currency. I've got all these kinds of services. And I want to expose these as software APIs. So let's just take that, say I'm I'm going to do payment, very simple example. Now I've got a payment service. And this mapping of this methodology is very straightforward. And I would say if somebody's going to start with a design, start that way. Align whatever the business services are, and if we're a target architecture, where they want to be 3 to 5 years, and work back from there to say, okay, I got my business service, I'm representing that in my software service. Now I've got that as an API. That API has to connect to this system, and it has to get this functionality from existing systems. Oh, we have a gap here, something that doesn't exist. Let's build that. So that would be my, in a nutshell, way to try to approach this. Really focus on what the business needs to support the services they are offering to their customers and their partners, and get that codified into an SOA design methodology. Domain-driven design is a good one, with the caveat that it's based on object orientation. So we have to kind of discard those parts that have to do with object-oriented design. But the concept of breaking things up into domains and subdomains is very good. We use a subset of TOGAF ourselves as another possibility.
There's a lot of good advice there, and the fact that the business should be driving the architecture.
Absolutely.
That's been true since the dawn of computing, right? That is a constant, as these technology waves come and go. So we only have a few minutes left. So I definitely wanted to get sort of why it is you joined WSO2. So we started working with WSO2 at Intellyx soon before you joined, and I was quite surprised as well as pleased that you had joined. But it just struck me that having worked with them, that I wouldn't have expected them to hire you. And so I'm just sort of interested why you took the job and what you're trying to accomplish there.
I didn't expect them to hire me either. So it was a surprise, but a welcome one. It started with Sanjeeva. I have known Sanjeeva for 20 years. You talked about the old web services days.
Yep.
I remember meeting him in those days and being in a lot of committees together. And Paul Fremantle I knew from those days as well. And I had always kind of kept track with WSO2. We used some of their technology at Credit Suisse, for example. So I've had contacts on and off. And what Sanjeeva explained to me about the company, he had been out as CEO and then came back and was looking to rebuild, to kind of restart and look for new directions and new strategies, especially around cloud native computing. And cloud computing, as you heard me talk earlier, this is one of my passions about how everything has changed because of commodity data center and all the innovations coming out of that. I was working on this at Citi. I was a part of the strategic team who was figuring out our cloud migration strategy, and I was doing work on microservices. I brought in OpenShift. I did a pilot on AWS. So I thought this would be great. I've got some background here that I think can be really helpful. Sanjeev was telling me the company is looking to change and evolve to the next level of growth, and it will be based on moving toward cloud native strategy. And on top of that, we have Ballerina as a kind of a secret sauce or secret weapon that has a tremendous potential as a cloud native language. I think we're not there yet, but one of the biggest problems I see in the industry is people understand I need to move to the cloud. But as we've been talking, there's a lot of things that are different, a lot of things you have to learn and change. People don't know how to do it. And the programming languages we have today are not designed for this either. We see a lot of efforts to sort of retrofit into Java capabilities you need for cloud native computing. It's like object-oriented COBOL to me. Why are you doing this? You need a purpose-built language for cloud native development. So that's another big reason why I joined. I see a lot of potential there.
I did it again. I keep doing that. I remember Ballerina from a few years ago when they first started talking about it, and I was scratching my head saying, why do we need this? That was before we were even talking about cloud native computing, and now you mentioned it's a cloud native language. So they really pulled a Wayne Gretzky, right? Skating where the puck is going to be, putting together Ballerina years ahead of when it really became something. And I think it's still a bit ahead of its time. So this is a good topic for the next podcast, right? We'll talk about Ballerina.
Okay.
Because we're out of time. We're out of time for today, and Ballerina is a whole topic in its own right, but it's definitely a good cliffhanger to leave our audience with. So yeah, really appreciate you joining us. And J.E., you want to take us out?
Yeah. Thanks, Jason and Eric, for the scintillating discussion today. And hope we'll get on with you again sometime, Eric.
That would be great, Jason. It's great to meet you. And Jason, wonderful to reconnect. And thanks for a great discussion. It was a lot of fun today.
Thanks a lot.
All right.
Talk to you soon.
Yeah,
until next time.
Thank you for listening to the Intellyx podcast. If you have any questions or ideas for future episodes, feel free to drop us an email at pr@intellyx.com. Until next time, keep on transforming.